In the 21st century, as technology becomes increasingly integrated into the field of defense, military forces around the world are constantly seeking new solutions to support soldiers on the battlefield. One of the most notable projects by the United States military in modernizing logistical capabilities is the development of the ls3 robot, the Legged Squad Support System. This is a quadrupedal transport robot designed to follow troops, carry supplies and equipment, and even act as a modern-day mechanical mule on the battlefield. ls3 was developed as part of an initiative by the Defense Advanced Research Projects Agency, DARPA, a branch of the U.S. Department of Defense dedicated to high-tech research. The project began around 2010 in collaboration with Boston Dynamics, a well-known company specializing in biologically inspired robots. The initial goal of the ls3 was to create a compact transport system capable of following infantry across challenging terrains such as jungles, mountains, or damaged urban areas, places where traditional wheeled vehicles struggle to operate. The robot needed to be self-balancing, agile, and capable of carrying significant loads of gear and supplies. ls3 has the appearance of a four-legged animal, somewhat resembling a large dog or a small bull. This design is not only symbolic but also highly practical, allowing the robot to move flexibly across various types of terrain. Some key features of the ls3 include load capacity. ls3 can carry up to 400 pounds, about 180 kilograms, of cargo, enough to transport weapons, water, ammunition, and gear for a small squad over several days. Operational range. On a single tank of fuel, ls3 can operate continuously for about 20 miles, 32 kilometers, enough to accompany units on extended missions. Speed. ls3 can reach a top speed of about 7 miles per hour, 11 kilometers per hour, on flat ground, and can still maintain a pace of 3 to 5 kilometers per hour on rougher terrain. Balance and stability. One of ls3's strongest advantages is its automatic balancing system, which allows it to stay upright and keep moving even after being pushed over or encountering unexpected obstacles. ls3 is not a traditional remote-controlled machine. It was designed to operate semi-autonomously or fully autonomously with the aid of various sensors and advanced navigation software. Cameras and LIDAR sensors. ls3 uses a system of cameras and LIDAR to see its surroundings, allowing it to determine its path, avoid obstacles, and track the movement of nearby soldiers. Voice recognition. An upgraded version of the ls3 can receive voice commands from its operator, a useful feature in combat environments where using hands to control the robot may be impractical. Squad tracking. ls3 is programmed to recognize and follow a specific soldier, usually the team leader, allowing it to move fluidly within a combat formation. ls3 is not designed to directly engage in combat or carry weapons. Its primary role is logistical support, specifically to carry gear for soldiers. This helps reduce the load on troops, enhances their mobility, increases endurance, and improves overall combat efficiency. In addition to transporting supplies, ls3 can also be used as a mobile resupply station or even as an emergency medical evacuation platform. With its ability to traverse rugged terrain, ls3 can reach heavily damaged areas to deliver essential supplies or evacuate injured personnel. Advantages: enhanced combat performance. When soldiers are not burdened with heavy loads, they can focus more effectively on their combat tasks. High mobility. The four-legged design allows ls3 to move in areas that wheeled or tracked vehicles cannot reach. Continuous operation. ls3 can operate for hours without needing rest, far exceeding human physical endurance. Limitations. Noise. One of ls3's major drawbacks is its loud engine noise, which compromises stealth during reconnaissance or ambush missions. High development costs. Developing and maintaining such an advanced robotic system requires a significant budget. Reliability in complex combat environments. Despite its autonomous navigation capabilities, ls3 has not proven entirely reliable when facing unexpected situations such as heavy enemy fire, destroyed terrain, or electronic warfare interference. DARPA and the U.S. Marine Corps conducted multiple ls3 field trials in diverse environments, including the Hawaiian jungle, California deserts, and rugged mountainous terrain. In these tests, LS3 was tasked with following military units, carrying equipment, and moving continuously for long hours. The results showed that LS3 was capable of traversing many types of terrain that conventional military vehicles could not access. However, its loud engine was criticized as being unsuitable for many real-world combat scenarios. In 2015, after years of development and testing, the LS3 project was officially put on hold due to various technical and practical limitations. However, this was not the end of the idea of using robots to support infantry. While LS3 was never formally deployed, the experience and technologies gained from the project laid the groundwork for future generations of military robots. Boston Dynamics continued developing other robotic systems, such as Spot, a smaller, quieter version, and many other companies are now researching autonomous logistics robots for military use. From LS3, the U.S. military and researchers drew several key lessons about integrating robots into combat operations. Sound and stealth are critically important. Any robotic system used in combat must ensure low noise levels to avoid revealing troop positions. Simplicity and reliability should be prioritized. A robot with too many complex functions may become difficult to maintain in real-world battlefield conditions. Autonomy must be paired with oversight. While AI can enable independent navigation, human supervision is still essential to handle emergencies or unexpected scenarios. Looking ahead, with rapid advancements in artificial intelligence, battery technology, and quieter motors, robots like LS3 may return to the battlefield in more advanced and effective forms. Though no longer in production, LS3 remains a pioneering symbol of the integration of bio-inspired robotics into military applications, paving the way for a future where robotic companions assist soldiers on 21st century battlefields.
Hey, let's go, let's go, let's go!